More review for the final, which is on Tuesday.
Did everything?
Next
Can you verbalize it
a
all?
week from tomorrow. Yeah, I think so.
Okay. Go ahead.
Graph y equals 2 to the power of x plus 4 minus 5.
What's the parent function?
1 to the power of x.
Actually, the parent function is going to be 2 to the x. Let's call this
Okay.
f of x, first of all. And we'll talk about a parent function as being g of x. The base is whatever base you're given. That graphs just like any other exponential function. You wouldn't be able to tell it if I showed you just the graph. Remember, it always goes through that point no matter what the base is.
Right.
What two adjustments are being made to this curve?
A horizontal shift and a vertical shift.
Okay, so relative to g of x, what is it? In other words, how would I define f of x in terms of g of x?
The equation or the graph?
Okay, here, let me give you the answer.
Oh, right.
That's what f of x is relative to g of x. Okay?
Right.
In other words, it's because the x plus 4 is in the exponent, that means it's got to be inside the parentheses, and it's a horizontal adjustment. The minus 5 is outside of the function completely, therefore it's got to be a vertical adjustment. So if we do this part first, there's no reflections, so I can do them in whatever order I want. If there were reflections, I would do all of them first and then everything else. So what's the first step? What's the consequence of having an x plus 4 there?
A shift to the left of 4 units.
Yeah, so a new point that I know it's going through is minus 4 comma 1. That'd be the first adjustment. Something like that. I haven't been that accurate, but that's not that important. And then everything's down 5. So this key point ends up down here with coordinates minus 4, minus 4. See how I got them?
Right.
And then it's going to do something like that. Now,
Okay.
when they ask you to do this, do they specify how many points you have to specify on the new curve?
No, it just says determine the domain and range.
Okay. So this 1 point is, everybody's fine with that? They don't need the y-intercept? They don't need the x-intercept?
Not with this problem, no.
Okay. Let's either look at the red. What's the domain on the red?
Negative infinity to infinity.
Okay. And then on the original black line, I had a horizontal asymptote where?
Y equals 0.
Where's my horizontal asymptote on this line?
Y equals negative 5.
Correct. So what's that make the range?
Negative and 5 with the parenthesis to positive infinity.
Very good. What else you got? Now,
Well, with
just,
this problem,
just to point it out, if I needed that point, what am I going to set x equal to?
0.
So it's 2 to the 4th minus 5. Whoa. That doesn't make any sense, does it?
No, it does not.
2 to the fourth
That's
16 minus 5. Maybe I just drew it wrong. In other words, I could have just drawn it wrong. All I know for sure is that it goes through that X that I've drawn there. What if it goes like this?
yeah, it does. It goes
It goes up
it
so
looks
fast that this intercept actually is 2 to the fourth minus 5, which is 11. 0, comma 11. So that makes more sense. Yeah, and you always kind of want to make sure these make sense.
right.
Just in case we did a left adjustment instead of a right adjustment or whatever. With this problem, it's pretty straightforward, but some of them can get pretty exotic, and you kind of need to draw it and make sense that it makes sense. All right, what else you got?
Yeah, let f of x equal x squared minus 2.
Like that?
Oh, I think we did this one last week.
Okay.
So never mind. Apologies. And can we go back to the last problem really quick?
Sure.
So to find the y-intercept, you set f of x equal to 0.
Not f of x. To find the x-intercept, you set f of x equal to 0. But to find the y-intercept, x is 0. When you're on the x-intercept, then you want f of x to be 0.
Right.
So yeah,
I'm sorry.
I was looking at the x-intercept. I would set that thing equal to 0 and solve it. That would tell me where y is equal to 0, which is the x-intercept. The key thing to remember on intercepts, always, there's two things. Y-intercept means x is 0, and the x-intercept means y is 0. Y being the same thing as f of x.
Okay.
Okay. Now, that's not the easiest thing to solve. We have to use logarithms to solve it. Because, if I'm setting that equal to 0, then I've got 2 to the x plus 4 equals 5. That's an exponential equation. I can't solve that with algebra. I've got to use logs. So I take the natural log of both sides, bring the exponent down in front. So you're going to end up with x plus 4 equals the natural log of 5 divided by the natural log of 2. And then minus 4. That would be the point on the x-intercept. That's the x-intercept right there. Natural log of 5 divided by natural log of 2 minus 4.
Okay. Right. All right. So how for parabolas, if I have the equation x minus 5 quantity squared equals 8 times y plus 3.
In parentheses?
Yes.
Okay. What's the question about this?
How would I graph that?
Is that all you have to do is graph it, or do you have to find the foci, and directrix, and all that good stuff?
Yeah, vertex, foci, or focus, directrix, and the lattice rectum.
All right. If I cannot remember what your general format is, but here's the general format that I think actually works best. It seems to me like you guys use A and not P, if I
Yeah.
remember correct. Okay, well, let's go back and do it that way then. There, let me write the general format. Well, since A is 1 over 4P, the A goes right there. So that's the general format. Right?
The one,
If you'll remember back to the general format of a parabola from your Algebra 1 days, y is equal to a times x minus h quantity squared plus k. Well, this is really no different than that. The only thing I've done is move the k to the other side.
right.
You with me?
Then wouldn't it be y minus k?
Yes. My apologies. Thank you. That is definitely y minus k. Okay? So if that is our general format, first of all, is that a vertical or a horizontal parabola?
Vertical.
Correct. That's our standard. So, and we know that P is equal to 1 over 4A. So first of all, let's move this 8 over to the left side. So we end up with, in other words, with the specifics you've given me, I can plug in this information. Now, that tells me the vertex. Where's the vertex?
5 comma negative 3.
Okay. What is the focal length?
2.
Which is P. Yeah, it is. Because P equals 1 over 4 times 1/8, which is 1/2, so P equals 2. So and we knew it was a parabola opening up, and that P is going to be a positive number because it's the distance from the vertex to the focus. So what are the coordinates on my focus?
5 comma negative 1.
Good. Do they want the directrix?
Yes.
It's the equation of the directrix.
Y equals negative 5.
Okay. And how does the latus rectum compare to P? Well, that sounds terrible, doesn't it? How does the latus rectum compare to P? I would have a hard time not laughing if I was a student and my teacher said that in front of a whole class. I guarantee you that at least half the students would be laughing their ass off. So
Yeah, it's I think I probably would if I liked that class.
it's
Not a huge.
it's 4 times whatever P is.
Right.
So the latus rectum is 8.
The whole length of it, though.
Right.
Not.
And that's just the measurement between, if you draw the horizontal line through your foci, that's the measurement, the horizontal measurement of that is 4 times the measurement from here to here.
Okay.
Okay. What else did they want? Did we get it all? Vertex, focus, directrix, latus rectum, anything else?
No, that's it for that one.
Okay.
So this one, I have to rearrange it, figure out if it's a circle, ellipse, parabola, or hyperbola, and then
So give me the polynomial. This is going to be in standard format.
it is x squared plus y squared minus 10x equals 0.
This right here tells you what it is. What is it?
Right. No, jeez.
It's a circle. It's a circle because you have an x squared and a y squared, and their coefficients are the same.
Right.
There's a plus sign between them. In other words, the moment you told me x squared plus y squared, I could have said it's a circle. If you
Okay.
given me something like this, x squared plus 2y squared, well, now I know that's an ellipse because it's still separating the x and y squared with a plus sign, and the coefficients are different.
Right.
Now, if you'd have told me x squared minus y squared, that's a hyperbola.
Right.
Because I still have an x squared and a y squared, and they're separated with a negative sign. If I said y squared minus x squared, that's also a hyperbola. All right, so back to this problem. We know it's a circle, so the only thing we have to do is complete the square to figure out, in other words, what's the general format for a circle? Oh, I got your, oh no, those weren't your sheets. Sorry. You don't get a cheat sheet, do you, for the final?
Not a cheat sheet, but my teacher said that the vast majority of the equations are going to be on the test.
Okay, so she'll give you the general, what is the general format for a circle, do you know?
X squared plus y squared.
Well, that's if the circle's at the origin. The more general formula is this. Excuse me, that's a y. Equals r squared. So we have to put our polynomial in standard format to make it look like this. Well, the way I do that is by gathering the x's together, gathering the y's together, and completing the square if need be.
Right.
And the secret, as with most of these, is to make sure when you go from step to step, you do not change things. In other words, the moment I wrote that, make sure that it's exactly the same as that.
Right.
And it is. Now, I don't need to complete the square and the y because there's no y term. So I know that the center of this circle is on the y-axis. It's not on the origin, but it's on the y-axis. So complete the square inside the parentheses.
Plus 25.
Okay, how do I balance that?
Add 25 to the other side.
Now rewrite that in terms of a binomial squared.
X minus 5 squared plus y squared equals 25.
Now you know how to graph the circle. Where's the center?
5 comma 0.
Yeah, I sorry when I said it was going to be on the y-axis. I said that, but what I really meant was the y-coordinate of the center is 0. Which does put the center of the circle where you said, which is 5 comma 0. It's on the x-axis. And then we know the radius is 5. Right? In other words, on the right side of the equation is the radius squared. So our radius has to be 5, which makes the circle tangent to the y-axis, because this distance is 5.
Right.
Okay? What else? We probably got time for maybe one more.
Okay.
Have you had all the way, you've had all the way through hyperbolas, haven't you?
Yes.
Okay. Let's
Actually,
make our last one either an ellipse or a hyperbola.
Yeah, hyperbola.
What's the polynomial, or is it in standard format already?
It was in polynomial, and I completed the square,
Okay.
and I got
What'd you get?
x minus 5 squared over 4 minus y plus 2 squared over 16 equals 1.
Okay. First of all, is this a horizontal? When I say horizontal or vertical on hyperbolas, I'm saying is the major transverse axis, the line that runs through the two vertices, is that horizontal or vertical?
Horizontal.
Okay. So I'm going to draw a box. I'm not going to dimension the box accurately. I'm just going to draw it. I'm going to draw some diagonals to it. Which dimension, what's the dimensions of that box? In other words, here, let me go ahead and even draw the hyperbola.
Right. It's 4 by 8.
Correct. So this distance, what are the coordinates of that major vertice? This one, right? Not the focus, but the vertice.
7 comma negative 2.
Yeah, I'm sorry. I don't know what I was thinking. Here, the easiest way to solve that is to just erase the axis, huh? Let's see. That was the center, and it's at 5, negative 2. So my axis must be about like that. Let's label the center. That is at 5, negative 2. So that vertice is how far over? What did you say again? 7?
7 negative 2.
Okay. And this vertice over here?
3 comma negative 2. Wait, can I ask a question really quick?
Sure.
So I know you didn't draw the box with dimensions,
Right.
but would the top end of that box be on the x-axis?
No, because the top end of the box is 4 units away. In other words, if I would have drawn it with proper dimensions, it would be taller than it is wide,
Okay, okay.
like that. And the dimensions of this box is 4 by 8.
Okay.
Okay? And then, of course, my diagonals would look a little different. But the points that we're labeling are the important part.
Right.
Whether I drew it to scale or not is another question. But what about, well, let's see, what else do we need? We need the foci?
Yes. Which that's what I was having confusion with. I had gotten this
What's the standard equation that relates the foci to A and B?
C squared equals A squared plus B squared.
Same as the Pythagorean theorem, which makes C equal the square root of A squared plus B squared, which in this case, C becomes the square root of 20, which becomes 2 root 5.
Yes.
So what is the coordinate of that red focus and this red focus?
7 plus 2 root 5 comma negative 2.
Actually, it's the center.
The center.
The focus is measured from the center. So it's
Okay.
not 7 plus 2 root 5, it's 5 plus 2 root 5.
Right.
Notice that 5 plus 2 root 5 is larger than 7. Root 5 is going to be 2 and change. So 2 times root 5 is at least 4. 5 plus 4 is 9, so it is to the right of 7,
Okay.
as it should be. And then this one over here is what?
5 minus 2 root 5, comma negative 2.
So you always start with your center, whether you're figuring out where the sides of this box are, or the top of the box, or the foci. Everything starts from the center, and you either add A, or add B, or add C to the center.
Okay.
And did they ask for the equation of the asymptote?
Yes, they did.
Okay. Well, the equation of the asymptote is going to be, first of all, the asymptotes are straight lines. So it's going to be in the format of y equal mx plus b.
Right.
What's my slope? And what's the general equation? Well, this is probably one that they'll give you.
Y equals mx plus b.
Well, it's y
Rise up.
plus or minus b
Over a
times
just
x minus h plus k, I believe. Is it not?
I thought it was just y equals plus or minus b over a x.
That's if it's at the origin. This is the more complicated. In other words, if it's not at the origin, it's this.
Right.
Hold on, I don't want to give this to you unless it's correct, though, and I know exactly what page it's on, because I have to look it up all the time.
So with the parabola, b is always the smaller value, correct?
With an ellipse.
Okay. When with hyperbolas, it's just b is under the y value, no matter what?
No. A is always measured along the major transverse axis. In this case, the major transverse axis is horizontal, going through the center. So A is measured along the horizontal. Always. Excuse me. A is always measured along the transverse axis. So if my transverse axis was vertical, in other words, if I had a hyperbola that looked like this, then this distance is A. And
Okay.
A would come under the y term.
Right.
And the slope of the asymptote would be A over B, not B over A. This is the right equation, incidentally. I looked it up. And that's only for horizontal hyperbolas. For vertical hyperbolas, it's y equals plus or minus A over B times x minus h plus k.
Okay.
Now, the one way to remember the equation of the asymptote is it's very similar looking to the vertex format. You got an A in front of an x minus h, only it's not squared, and you got the plus k. So take your squared and add the b, and you got the equation of the vertical or of the diagonal asymptote. William, I got to run. I'm late already for my next appointment.
You got it, Mr. Count. Thank you very much.
Okay. Talk to you whenever is the next one. Bye-bye.
Yeah, I'm sure when